Hello, welcome to the video. In this lesson, we're going to be looking at section 11.3, where we're going to be looking at shapes of distributions. Here it says they're asking us, how can you use a histogram to characterize the basic shape of a distribution? So the first thing that we're going to look at is how we make a histogram chart, and then um, how can we use that chart to describe the distribution. So here we have everything that's in like these bars is the histogram chart. So these bars, however the data is categorized, and each bar is going to be represented by the frequency that it is being used in that particular category. So, and I'll get into how we make that in a little bit. One of the things that you do have to keep in mind that it is like a bar graph, and there are no spaces in between these bars. All right, so they're going to be like kind of like right next to each other when they get created. And um, what we can take from these histogram charts is we can develop uh, some type of distribution and see if it's something that's skewed either to the left or to the right, or if it's something that's symmetric. So here it talks about a skewed left, which means that the tail of this distribution is more on the left hand side. Symmetric means it's kind of equally left and equally right. And then skewed right here shows the tail is more on the right hand side of our histogram chart. Okay. So if we were to look at a piece of data like this one here, here they want it says the frequency table shows the numbers of raffle tickets sold by students in your grade. Display the data in a histogram, and then they want us to describe the shape. So here it talks about tickets sold, and they have it categorized um, and looks like uh, an evenly distributed number. So it looks like it's in sets of 8. So it's like 1 through 8, 9 through 16. So what we're gonna do here is I'll try to kind of make it neat, and you can too. So you can kind of like take like a straight edge and kind of make a graph here, kind of make a graph here, and then try to even out the values here. And what I'll do is, since let's see here, my largest frequency number is 25, I'm sorry. I'll try to make these in like increments of 5. So like 5, 10, 15, 20, 25. All right, so I did the best I could to try to fit these in. So this is 5, 10, 15, 20, and 25. So now from here on the bottom, I'm gonna try to, so like I'll start here. This is 1 through 8. Over here is 9 through 16. Over here is 17 through 24. Here is 25 through 32. Here, 33 through 40. Here, 41 through 48. And here, finally, 49 to 56. So looking at the first one, we got 5. So I'm just going to go up to 5, make my chart. Next is 9, so it's not quite to 10, so look something like this. Uh, 17 to 24 is 16, so it's a little bit larger than 15. And so here, 25 to 32 is all the way up to 25. Make my chart here. 33 through 40 is at 20. It's like there. 41 through 48 looks like 8, so not quite 10. And then finally 49 to 57, so just a little bit smaller than that. Okay, so we have our histogram of the frequency of number of tickets sold. So what they're asking is to describe the shape of the distribution. So is it skewed left, is it skewed right, or is it relatively symmetric? So if I look at this, you know, like so, it basically looks like the tail um, of the graph seems to not go any more left than it does right. So my my best assumption here would be that it's symmetric. Okay. Same idea here. Um, in this particular one, they found shows a table of pounds of aluminum cans collected by classes for a fundraiser. Same idea. You have it categorized. Looks like it's in increments of 10, and then you have the frequency here. So same idea. I'm gonna make my histogram chart here, try to make it a little bit neater. And my largest number is, looks like 34, but so I'm still going to do it in kind of increments of 5. So I got 5, 10, 15, 20. If I want to make this one a little straighter. No, that wasn't very good either. That's better. Maybe this one goes a little lower. So 5, 10, 15, 20, 25, 30, and we'll say 35. Okay, so I'll write it in 5, 10, 15, 20, 25, 30, 35. Okay, so on the bottom, make my what 1 through 10, another one 11 through 20, another one 21 through 30, another one 31 through 40, 41 through 50, and finally 51 through 60. So go up, looks like it's 7 is here. Next is 8, so that's a little bit larger. Next is 10. Here we got 16, so a little bit larger. And then we jump all the way up to our 34, so it's not quite to 35. And then finally we get to 15, which is right about there, we'll say. All right, so looking at this one, you know, it looks like the tail is more over here on the left, so I would say that it is skewed left as my description. And then here it talks about, it says choosing appropriate measures. It says when a data distribution is symmetric, usually what that represents is the mean is described as the center. And then you can use standard deviation to describe its variation. When the data distribution is skewed. Usually you're going to use the median to describe the center, and then you'll use those 5 number summaries to describe your variations, like your first quartile, your third quartile, largest value, smallest value, stuff like that. So what we have here, it says a police officer measures the speeds in miles per hour of 30 motorists. The results are shown in a table at the left. So this is the results they gave of the 30 um, motorists. First, they want us to display the data in a histogram using 6 intervals, beginning with 31 through 35. Second, part B, they want us to measure the center of variation that best represents the data. And then it says here, the speed limit is 45 miles per hour. How would you interpret these results? So, all right, so what we can say here is, I guess the first thing we're gonna do is let's make a frequency chart, kind of like what we saw like in like this right here, to kind of help us make a histogram. So let's make a little frequency chart. So I'll write speeds here. I'll write frequency here. And they wanted you to start with 31 to 35, and they wanted you to make 6 of them. So 31 to 35 here. So I could say what? 36 to 40 here. I could say 41 to 45 here. I can say 46 to 50. I could say 51 to 55. And 56 to 60. 1, 2, 3, 4, 5, 6. So 6 intervals. All right, so what I'm going to do here is I'm just going to go through each one of these, and I'm just going to kind of make a little dash mark in uh, which one that it shows up in. So 32 goes here. So cross that out. 53 goes here. 56 goes here. 50 is here. 55 there. 51 there. 54 here. 52 here. 55 here. 45 here. 44 here. 38 there. 41 here. 50 here. 45 there. 53 here. 60 there. 50. 40. 58. 39. 48. 42. 55. 49. It's over here. 52. And then 55, 52, 60, and then finally 47. So looks like we got 1, 3, um, so hold on. So looks like I got 6, I got 5, I got 11, and I got 4. Make sure I did this right. Just hold on a sec. Sorry, I did. So actually this one, my bad. This should be 5, and then this should be 6. Okay, sorry about that. I just wanted to double check. So here's all the frequency numbers. Okay, so let's make our table here. So again, and my largest number is 11. So what I'll do is I'll make them in increments of 2. So we'll go 2, 4, 6, 8, 10, 12. All right. I believe that's pretty even. All right. Let's see if I can straighten that one out. Okay, cool. So 2, 4, 6, 8, 10, 12. So starting here, this is what, 31 through 35. Here is 36 through 40. Here, 41 through 45. Here is 46 through 50. Here is 51 through 55. And then finally here, this is 56 through 60. So first off, we have a frequency of 1. So it's going to be right here. Next is 3. So right about there. And then 5, right about there. And then we got 6, so it's just a little bit higher than that. And then we got 11. And then finally we got 4. Okay. Uh, so we got our histogram, we got our frequency table. So now it says which measure of center and variation best represents the data. Well, since it looks like it is skewed left, I would say it's going to be the median, all right, because it's not symmetric. And then finally it says the speed limit is 45 miles per hour. How would you interpret these results? Well, looking at the frequency table, it looks like a majority of these motorists were going faster than 45 miles per hour. So you could say that most of the motorists were speeding. So that's how I can compare that. All right. Here it says economists and graphic symbols that represent facial expressions. They are used to convey a person's mood in a text message. The double histogram shows the distribution of economist messages sent by a group of female students and a group of male students during 1 week. They wanted you to compare the distributions using their shapes and appropriate measures of center and variation. So on the top, you have the female students with the text messages, and on the bottom, you have the male students with the text messages. And what it's showing is the frequency of that represents the facial expressions. So by looking, I would just by looking at this data, um, because if you look at the data on the right of the distribution for female students, um, the it's approximately a mirrored image. So I would say the data is symmetric. So I would probably use the mean for our center of variation. looking at the male students, I would say that since it's kind of skewed to the right, I would use the median to help us with these to determine the best representation for that for the center variation. All right, so last example here it says this table shows of a survey that asks men and women how many pairs of shoes they own. They want you to first make a double box and whisker plot that represents the data. Then they want you to describe each of the distributions. Okay. All right. So first off, let's make our box and whisker plot. So let's like the one for the for the men. So because it's the first one here. So for the men, we got to find those five numbers. So we got to find the well, we got to find the the median. So the median is here. We got to find first quartile, third quartile, and minimum and maximum. So looking at that, so if I go here, I got 2. My first quartile is 5, so it's right about, I'll say right about here. So that's 5. And my third quartile is 10, so let's see here. So I'll just go 10 right here. And then 7 is my median, so I'll go here. And then my max value is 17. I'll go a little bit larger there and say it's 17. Now, for the women, I'll just make it a different color. My minimum was 5, so it's right there. My first quartile was 12, so it looks like I'll say it's right about there. My median is 14, so, and then my third quartile is 17, so it's about the same. So it's about 14. So we got what, 12, 17, and then my maximum number was 24. So it's somewhere over there a bit. Okay. All right. So actually, I can even make this, try to make this a little bit more accurate. So it's right about there, we'll say. Okay, so there's my box and whisker plot. So this is for the men, and this is for the women. Okay. So we got our box and whisker plots, and they want us to describe the distribution. So going back to what we talked about in box and whisker plots, um, the whisker here on the men is more to the right. So I would say that um, it would be more skewed to the right. For the women, the whiskers seem to be pretty even. I would say it's symmetric. All right, so they want you to compare the number of pairs of shoes owned by men to the number of pairs of shoes owned by women. So I would say since you've looked at it, it says by the looks of the box and whisker plot, it says the centers and spreads of the two data are quite different. If you look at it, you know, the mean for women is twice the mean as men. It's even twice as the median. Um, so there is more of a variation in numbers of pairs of shoes owned by women. That's what comparison I would make from uh, from the data here and from the box and whisker plots. Here, it's asking, it says, how many of the women surveyed would you expect to own between 10 and 18 pairs of shoes? So 10 and 18 pairs would be somewhere between here and here. Okay. So before we get into what that value is, what we're going to look at is kind of the distribution of a bell curve and how it is represented with respect to standard deviation. So if you look here, if I were to make a bell curve like so, all right, the middle right here is your mean, okay? Then the next line that comes down right here is going to be both plus and minus whatever the standard deviation. So this is going to be plus the standard deviation, and this is going to be minus the standard deviation, whatever it happens to be. This, the stuff that I just lined up here, makes up 68% of the data within one standard deviation of the mean. All right. Next, you're going to have plus 2 times the standard deviation, both plus and minus. What we have here is now we have 95% of the data within 2 standard deviations of the mean. Okay. So using this to help us out here, if you look at the women's standard deviation, it's 4. So if you look at their mean, if you took 14 minus 4, it's 10. And if you took 14 plus 4, that's 18. So that is what they're asking with respect to the plus and minus of one standard deviation. So what we can say is, all right, well, how many people were in the survey? For women, there were 40. So because they want you to figure out what's within one standard deviation of the mean in this case. So they want you to figure out 68% of the women that were in the survey, and that will determine how many women own between 10 and 18 pairs of shoes. So you can take the number of women in the survey, which was 40, and you're going to multiply it by 0.68 because you represent it as a decimal. 40 times 0.68 is about 27. So about 27 uh, women will have owned between 10 and 18 pairs of shoes. And that is looking at shapes of distribution. Hope this helps. Till next time.